Alright, let me check that the microphone is not too high. Well, not settings, but sound. It's probably fine. I think it's fine. I think it's fine. Yeah, so let's continue with our exploration of Vue.js.org. Next thing, reactivity fundamentals. API reference. This page and many other chapters in this guide contain different content for Options API and Composition API. Your current preference is Composition API. You can toggle between the API styles using the API reference switches at the top of the left bar. Very cool. As I said, we'll keep even the title change. There is an entire different documentation. I thought it was only the code snippet, but no. Of course, it's the text, even the headings, the whole page. Let me sip my coffee. So, okay, that's very cool. Let's stick to Composition API. Declaring reactive state. We can create a reactive object or array with a reactive function. Import reactive from Vue, const state equals reactive, and we pass this argument, which is an object with a count with a value 2. And then we add some wrapping around this object that turns it reactive. What does it mean? Well, we'll see. Reactive objects are JavaScript proxies and behave just like normal objects. A JavaScript proxy is a bit hard to explain for me now, but you basically pass in a target, and then you can attach handlers to it that run when we access that target, like we access its value, and when we change the value on the target. Like here, if we access the target, the get hook will be run, and if we change the value, there should be a set. Yeah, the set hook will be run. So we can attach like effects to reading and writing values. That's a proxy. So they behave just like normal objects. They are objects, JavaScript proxies. The difference is that Vue is able to track the property, access, and mutations of a reactive object. If you are curious about the details, we explain how Vue's reactive system works in Reactivity in depth, but we recommend reading it after you have finished the main guide. See also typing reactive. To use reactive state in a component's template, declare and return them from a component's setup function. Declare and return them from a component setup function. Yeah, so that's the, well, we again import reactive, then we export an object, and this object has a key setup, which is a special hook dedicated for Composition API, and inside this setup function, we declare this reactive state, and then we return it. That's the key. We wrap it in setup, then we return it, the reactive state. So that return exposes the state to the template, like this. Then in the template, we can use state wrapped in the mustache, like this. Like, see, we declare the state. The state is a reactive object with a key count, which has a value 0. So we can access this value doing state.count. Similarly, we can declare functions that mutate reactive state in the same scope and expose it as a method alongside the state. Same as before, inside the setup we declare a function that increments the state count by 1, and then we return it. We return this increment. So in the template, we can use the increment function as an event handler. When we click this button, we run this increment function, and then we update the state count by 1. And that's, if we go to the playground and we import reactive from view, we declare state, which is a reactive property which wraps a count with initial value 0, and we declare a increment method which increments count by 1. And then here we can have a button with an event listener on click, which runs increment. And then inside we have the message syntax with a state.count. And there you go, it works. Notice that we have a script setup. We have seen this before, maybe not in too much detail, but the script setup replaces the setup. I think that here we could remove the setup, and then we could do export default, and then we copy all these things here, and then we return whatever things we need to access from the template, which in this case is the state and the increment. Okay. I don't know if there's a way to like auto-format it. That would be really nice. Unexpected keyword const. Oh yeah, look, we need to wrap it in the setup hook. The whole thing, the entire thing. Otherwise it's not gonna work. I really want auto-format here because that looks ugly. Anyway, now this is using the setup syntax. It's the same thing. You know, that's how it works. We increment the value on click on the button, and the value shows up, as you can see, immediately changing. Okay. There you go. Script setup. Manually exposing state and methods via setup can be verbose. Luckily, it is only necessary when not using a build step. When using single file components, we can greatly simplify the usage with script setup. Alright, so what they are going for is that script setup should be the default mode of using the composition API. Alright, yeah, I like it. I like it a lot. So let's have this thing here, and it's the same thing. Script setup, reactive state, increment. The thing is that you don't need to wrap it in the setup function, and you don't need to return it. So everything inside script setup which is declared is automatically made available to the template. Top-level imports and variables declared in script setup are automatically usable in the template for the same component. That's just what I said. For the rest of the guide, we will be primarily using single file components plus script setup syntax for composition API code examples, as that is the most common usage for Vue developers. DOM update timing. When you mutate reactive state, the DOM is updated automatically. However, it should be noted that the DOM updates are not applied synchronously. Instead, Vue buffers them until the next tick in the update cycle to ensure that each component needs to update only once, no matter how many state changes you have made. To wait for the DOM update to complete after a state change, you can use the next tick global API. So what it's kind of saying here is that the DOM doesn't update for every single change that we make. It waits until a batch of changes have been done and it buffers them, and then when something called next tick happens, it updates the DOM. And here it's telling us we can explicitly wait for the next tick with this next tick function. We have to import it from view, and then, for example, inside the function increment, we update the count value, and then we use the next tick function, and inside the next tick function, we can have access to the updated DOM. One second, because it's way too hot in my room, and I need to bring the heating down. There you go. Okay, I'm not fully. Basically, all the changes triggered by whatever we did in the setup function or running any other functions will be accessible here. Let's try to figure out, doing something very simple. We import next tick. I'm not sure, I don't know what's gonna happen now. Let's explore a little bit. We're gonna run next tick here, and inside it, we're gonna have a function which logs in the console the value of state.count. And we are gonna log it outside here also, like that. All right. And we're gonna take a look at the console, and we are gonna click the button. Yep, they are both the same. Okay, let's not get ahead of ourselves. So whatever changes happen in every tick, inside the next tick function, we can have access to all the changes already done. It's just that the example we have may be too simple yet to be able to test that. Let's move forward. Deep reactivity. In Vue, state is deeply reactive by default. This means you can expect changes to be detected even when you mutate nested objects or arrays. Import reactive from Vue const object, which is reactive, and inside has a nested object and a nested array. Function mutate deeply. This will work as expected. Object nested count plus plus object array push bath. Okay, that is very cool because we don't need to do any kind of strange magic to update these things. It is also possible to explicitly create shallow reactive objects where the reactivity is only tracked at the root level. However, they are typically only needed in advanced cases. Let's test this thing. Let's have this thing. We can just replace this whole thing. We don't care about that. Let's get rid of next tick. And then here we can have our object. And then we can here have our mutate deeply. And why am I seeing all these errors here? Let's clean the console. Yeah, let's put the object outside because it's a bit kind of confusing to have it. Let's actually have it, how is that HTML selector like this? Yeah. And then we have a button which says click me. Let's call it mutate me deeply. There you go. Oops, can I do that? Why? Oh, what is happening here? Illegal tag name. Oh, sure. Yeah, now I'm kind of wasting time here. There you go. Mutate me deeply. We have a nested object, and then we should see how the count increases, and we push an additional item inside this array when we click it. And it happens, and you can continue doing that. Okay, so that's what it means with the nested. We can mutate objects as deeply as we want, and the reactivity will still work. And this means that if we click this, if this didn't work when we click this button, the value of this object would change, but reactivity would not work for deeply nested objects and arrays, so we wouldn't see this changing. We wouldn't see any change here. That's what it means. But we see the change, so it works. Hopefully that makes sense. But we can also override this functionality, although that's something for an edge case, basically. We will not do that often. Reactive proxy versus original. It is important to note that the return value from reactive is a proxy of the original object, which is not equal to the original object. We have a raw object, and then we have a proxy of the raw object, and then if we try to check for equality, they are not equal. Only the proxy is reactive. Mutating the original object will not trigger updates. Therefore, the best practice when working with Vue's reactivity system is to exclusively use the proxied version of your state. To ensure consistent access to the proxy, calling reactive on the same object always returns the same proxy. And calling reactive on an existing proxy also returns the same proxy. Okay, yep, that makes sense. That's good. So if we call reactive on the raw object, we get a proxy, and that's equal to the existing proxy. And if we try to make a proxy reactive, we get the same thing. This rule applies to nested objects as well. Due to deep reactivity, nested objects inside a reactive object are also proxies. Yeah, that makes sense. We have a proxy, which is a reactive object, and then we have a raw object, and we nest the raw object inside the proxy. Then the nested proxy is different than the raw. Okay? All right. So if we add things to a proxy, they automatically become reactive without us needing to do anything. That's really good. That's possible with the proxy JavaScript API. This API, proxy JavaScript, this API is great. That makes everything possible. I wonder how new that is. Internet Explorer cannot use Vue 3. The entire Vue 3 relies in this proxy API. Mm, I'm not sure how to check when this was released. When was proxy API released? When was JavaScript proxy API released? ES 2015. Okay, so it has like 5 or 6 years. Let's go continue. Limitations of reactive. The reactive API has two limitations. It only works for object types. Objects, arrays, and collection types such as map and set. It cannot hold primitive types such as string, number, or boolean. Since Vue's reactivity tracking works over property access, we must always keep the same reference to the reactive object. This means we can't easily replace a reactive object. We have a reactive state, and then we we reassign the state to another reactive object. We cannot do this thing? Okay. What happens if we try to do this thing? Let's try. Will it error out? Or what does it mean? Let's put a div in here with a state. It says it will not work. Let's make an increase function for this state count plus plus. Let's make a button. Oops, I do prefer Visual Studio Code, but well, click increment state.count. This doesn't work. This thing doesn't work. So if we reassign the state to another reactive object, and then we have this method increase, which increases the count of the state, this thing actually doesn't work. Okay, so let's get rid of this. Wait, I'm doing something wrong here. State count, click increment. Oh my god. God damn it. Let's call it increment. There you go. This works. I'm not sure what is happening here. I think what it means, const replace state. I have like no idea now. I'm speculating. I need to do this. So if we do this, basically, we are gonna replace a state, and we are gonna create a button with a listener. No, don't show me this thing. I want to see my code. With a listener replace state, and inside here we're gonna show the state count. That's the first. I'm gonna get rid of the second. And yeah, let's click here. This doesn't work. Yeah, this doesn't work. The state's replacement doesn't work. The state is still 0. As you see, so when we run replace the state, we reassign the state to a different reactive object with count value equal 1, but still here we see 0. So that's not reactive. That's what it's saying here. We must always keep the same reference to the reactive object. That means that if we can't do something like that, we need to do state.count equal 1 here, basically, and then this thing works. It becomes 1. It also means that when we assign or destructure a reactive object property into local variables, or when we pass the property into a function or destructor properties from a reactive object, we will lose the reactivity connection. We have a state, reactive state. We declare a n variable, which is equal to the state.count, and then we increase this value of n. And it's telling us this doesn't affect the original state. Count is also disconnected from state.count. So we are destructuring here count from state. And if we do this, then it doesn't affect the original state. And the function receives a plain number and won't be able to track changes to state count. Okay. So we need to change the object and its keys directly. We have to mutate the state. we have to apply mutations to the state for it to work. We cannot grab values from the state and put them inside some other variable and then reassign the value of that variable. Yeah, that doesn't work. Reactive variables with ref. To address the limitations of reactive, Vue also provides a ref function which allows us to create reactive refs that can hold any value type. Import ref from Vue, and then we declare a ref with value 0 accessible through count. That's to circumvent the fact that reactive doesn't work in primitive types like booleans or numbers or strings. For those, we use ref. Ref takes the argument and returns it wrapped within a ref object with a dot value property. So we do the ref of 0, we assign it to count. Count is now a reactive variable. This is wrapped. This is an object which grabs the value 0. If we console log it, it's, as you can see, it's an object with value equals 0. To access the 0, we need to do count that value, and to increase the value, we need to change this property, count that value. That's how refs work. That's the thing. See also typing refs. Similar to properties on a reactive object, the value property of a ref is reactive. In addition, when holding object types, ref automatically converts its value with reactive. Wow, I didn't know that. When holding object types, ref automatically converts its value with reactive. A ref containing an object value can reactively replace the entire object. If we have a object ref like this, what we use reactive for before, then we do object ref dot value equals count. This works reactively. So if we want to be able to reassign, yeah, it works of course it works reactively. It's the same thing we have done before with a primitive, but now with an object. And we can reassign the value of the ref like this. This didn't work for a reactive, but it works for a ref. Okay. Refs can also be passed into functions or destructed from plain objects without losing reactivity. Okay. We can make an object with refs. The function receives a ref. It needs to access the value via dot value, but it will retain the same reactivity connection. Okay, clear, yeah. Because in here we are not passing the value of the ref, we are passing the reference itself. We are passing in the reactive object. And this is still reactive because the object itself is not reactive. What is reactive is the references inside, in this case, one bar. In other words, ref allows us to create a reference to any value and pass it around without losing reactivity. This capability is quite important as it is frequently used when extracting logic into composable functions. All right. Yeah, that's an important difference from reactive objects. Ref unwrapping in templates. When refs are accessed as top-level properties in the template, they are automatically unwrapped, so there is no need to use .value. Here's the previous counter example, using ref instead. We have a script setup, we import the ref, then we have a const count with initial value 0, which is a ref, so our reactive value, and then we have an increment function that increases the count.value by 1. And here in template, we run the increment function, and then here, instead of having count.value, we have count. So in the template, references are automatically unwrapped. No value needed. Note the unwrapping only applies to top level properties. Nested access to refs will not be unwrapped. Ah, sure. Const object equals foo, which is a reference, and then the object.foo does not get unwrapped. Let's um, let's replace all that by this. Then we have this same thing, which we don't need to return the value of. We don't need to do dot value here. But now here we also have this thing, object, and then let's put a div here where we access the object dot foo. Wait. I see a 1 here. This object is foo1, and then we do foo. It seems to get unwrapped. If we do value, it's still the same. We are getting the value. We are getting the value 1. So I don't know. It seems to work. It somehow, well, it says it doesn't work, but it somehow seems to be smart enough to know what to render. We can fix that by making foo a top level property. Const foo object, sure. Okay, we can do this. We have the foo, which is a reference to the ref inside the object. So we can do foo now here. If we do foo.value, yeah, that doesn't work now. So this thing somehow is smart enough to know how to handle that case, even though the documentation says it doesn't work. No foo will be unwrapped as expected. Now, yeah, as expected. Ref unwrapping in reactive objects. When a ref is accessed or mutated as a property of a reactive object, it is also automatically unwrapped, so it behaves like a normal property. Count is a ref, then we have a state, which is a reactive state and which has the count inside. we can console log the state.count and we get the value 0. We don't need to use dot value. If we reassign the state.count to 1, then the count.value actually changes to 1. So we can combine refs and reactive. If we use ref inside our reactive, then the ref gets unwrapped, but the link to the ref still remains. So if we access the ref from the reactive, we don't need to use dot value. Right? Like here, we are not using dot value to access this because we are accessing it from the reactive object. So the count gets unwrapped. And then the link is not lost because if we reassign the state.count, we give it a different value, the original count changes value. Okay, so that's good to keep in mind. If a new ref is assigned to a property linked to an existing ref, it will replace the old ref. So we have a other count ref with value 2. We have state count equals to other count. The state count is coming from here, I guess. We console log state.count is 0 and the original ref is now disconnected from state.count. Yeah, okay, we are replacing the count by the new count. So the new count is 2 because it's the value the new count has, this ref. And the old count, accessing it directly without the reactive object, still is 1. Yeah, so okay, so we don't reassign the original ref if we do this thing. Ref unwrapping only happens when nested inside a deep reactive object. It does not apply when it's accessed as a property of a shallow reactive object. Okay, so if we have a shallow reactive object, in this scenario, if state was a shallow reactive object, we would need to access state.count.value, not state.count, I think. Unwrapping in arrays and collections. Unlike reactive objects, there is no unwrapping performed when the ref is accessed as an element of a reactive array or a native collection type like map. So if we have a reactive array with a ref inside, we need to access the ref inside the array with dot value notation. And we have a reactive map with a with an entry count with value ref with value 0, which is a reactive, and we need to access map.get count.value. So this is going to return the ref, and we access the value of the ref with dot value. All right. Okay. Yeah. That I believe I begin to feel that this needs some studying, some practicing, because I see lots of potential gotchas here. It's complicated. I think we need some kind of workflow to minimize the kind of potential errors that this could generate. Maybe try to use always only refs or something like that. Reactivity Transform is an experimental feature, this thing. Having to use value with refs is a drawback imposed by the language constraints of JavaScript. However, with compile time transforms, we can improve the ergonomics by automatically appending value in appropriate locations. Vue provides a compile time transform that allows us to write the earlier counter example like this. Let count $ref function increment count. Click OK. Let's try this thing. This is experimental and may change before being finalized. We have this dollar. So now that's easier. We don't need the dot value here. The dot value, I can tell you, it often leads to errors and unexpected things and gotchas because it's easy to miss or forget. All right, let's take a break and then we'll continue with computed properties, shall we?